Hi. So I'm going to explain the usage of the UML Checker toolset and one of the features internal interaction testing. So in this example, we have a SpreadsheetEngine. So we have an implementation in Java. So SpreadsheetEngine provides an API. We also have a simple command line interface, and we also have a model. So this model has a structural part where you have a class diagram with structure of, so we have the main concept here is that of a spreadsheet can have cells with a name. A cell may have a value or a formula. A formula is represented internally by an expression, a tree expression. So form can be a reference to a cell, a constant, or a binary operation with left-hand side and right-hand side. There is also a parser that parses the string representation and gives back an in-memory representation. And then we also have a simple command line interface that allows some commands from the user and invokes the API just for simple testing. So this structural part. In the dynamic view, we have two sequence diagrams, one illustrating how the spreadsheet engine can be used by client application through the API, and another one explains how it can be used through the command line interface. So in this case, I'll focus on this one. So this diagram explains, in this case, it explains how a client application can use the API. So it's the, let's say, first level of this diagram is to explains that, illustrates. So basically it has that the client application can create a spreadsheet, can add cells with some name to it, can assign a value to a cell, or can assign a formula to a cell. And then it can get the value of cells. So this value can be given or calculated. So in this case, this cell has a formula, so the value will be calculated. But the interesting thing is that besides explaining how the API used by client application, you can also illustrate how it works internally. And this is a diagram that basically illustrates how all the methods in the and classes in the structural model are used in this scenario. So it shows what happens internally, namely the parsing process. So it has to create some objects internally, and also the evaluation process. So it's going internally. Now, if we run this, so we have an implementation in place. We have a model for this, and if we execute with our, it's already configured. So if we just execute, it will take a few seconds. So it will generate test code. Test code will be available also inside Eclipse. Execute test code and present results. So results are presented in the model. So in this case, we have a problem. Okay, we have a problem because there is a problem. Detected problem internally. So the parser, there is a problem in the parser that is invoked, but we have a problem here. If we check, note there is a problem, missing call exception. That's the problem. So this the parse method of the parse is not calling this. Let's see. If we go to the implementation, we can see here. What happens really is that parser is doing nothing. It's just returning null. Okay, but we can do one thing here with our approach. So one thing we can do is that, okay, if the implementation is not, for the parser is not done yet, we can mark this as a stub. Okay, and now if you execute tests again, so I'm illustrating users the injection of test stubs. Now if we execute again, the test harness will take care of the behavior related with the parser. So it will return the proper value, and it will send these calls properly. So that's the test. The test harness will do that for us. So I'm going to execute again. No. So it's generating again, and we have the results. In this case, we have one failure. So what happens in this case? So that problem disappeared, and now what we have is that for one combination of parameter values. So we have basically 4 combinations, so each combination is a test case. In the last one we are exercising the binary division, and there is a problem in this case. And if you look at the diagram, okay, we see the problem here, we see the notes, and says there is some value that was expected, so is a return value exception, the wrong value was returned. But this is also an internal error, so you see the problem is the return value of this eval method in bin op class for the division. So if you look at the source code, if you go to the bin op class and you check the method, so it's the eval method, we have it here, and the problem we have is in division. Okay, so if you look at the code, okay, we see a typical bug, it's a copy paste error. So if we fix this error, we recompile project, and now we execute again the plugin. Let's switch just this test code. So okay, now we execute the plugin. It's okay, taking a few seconds, and everything is okay. So everything is fine now, everything passed. If we go to Eclipse, so the test case, the test code is generated here. You can see by the time this was done. This is the test code for this diagram. So we have the encoding of the sequence diagram here, with the expectations, the invocations, and checking things. And we have each combination of parameter values generates a test case. You can run it here. There's a unit test also. And it passed. Okay. Now let's assume that we have implemented the parser. Okay, let's check the parser. We have an implementation now. Okay, we have really an implementation in place. Okay, everything is done. And now we want to use the actual implementation, so we go back here. This is already implemented, so we remove stereotype and we run things again to see if this implementation is working properly. Execute it again, a few seconds, wait a few seconds, and see what happens. Something is wrong, and okay, this is not occurring. Get cell by name. There is some problem here because perhaps we didn't recompile, so we have to recompile because we are using compile time weaving. Perhaps that's the problem. Let's just check again. Okay, now everything is okay, so okay, this is just so I forgot to recompile it. Okay, so this is the test step, and we can of course execute also here, and everything is the same code is running properly. Okay, now I'd like to illustrate another thing. So I have this sequence diagram illustrates how the SpreadsheetEngine API can be used by a client application and how it works internally. And it basically exercises all the methods in the API. This spreadsheet, now let's illustrate how to model and test the user interaction. So what happens in this case is that the spreadsheet, so we also have SpreadsheetEngine also comes with a simple command line interface. Basically it's a class that has a main method that allows a user to experiment with simple things like enter a string like this. So we can define a variable and assign an initial value, and in this case what to expect, so we can start the application. This is a keyword for modeling user interaction. So in this example the client represents a user. It can start the application, then it will enter something, and when we enter, this is an assignment, it creates a variable an assignment, and then here we are evaluating an expression, and then in this case we have a result, and then we finish. So and here we describe the user interaction, also how this command line interface interacts with the rest of the API. So when you start to create an initial spreadsheet, when you enter something like this, it will create a cell and it will set the value, when it is an expression, it will ask the evaluation to ask the parser to evaluate everything and return. So we don't, in this diagram, we don't explain how other things that are working internally because you already explained. And we just model what we want to model. So if we execute this now, it's running, and everything is okay. Okay, so so this is what's happening is in user interaction testing. Just to show you just something that might happen. So if we have some error in the implementation of this command line interface, let's say, so okay, you don't evaluate things. Okay, let's assume you have some bug here. Okay, so you're not evaluating the expressions. So now if you go here, you execute. Okay, we have a failure. Okay, there is a problem here. So let's see what is missing call exception. So it was not from this cell was not being created. So that's the so just put things back. Okay, and just put everything okay. Now let's get this again. Now we should have everything properly running. So it will present, expect everything to be okay now. So the implementation, okay, we still have a problem, but okay, there is a problem here. Okay, there is a problem with display value. Okay, there is a problem in terms of output. Let's check here. Let's get. I think the problem is that okay, I think we have an error here because we did this wrong, so we have to write. Yeah, we have some problem here. Yeah, there is a we injected a bug here, so that's a problem. Let's fix this. Now we can execute again. Everything is okay, so all tests are okay now. We can run the tests here. Okay, everything is okay. The same thing here, we can execute everything just to finish the demonstration. So everything is okay. And this. So in this demo, we presented internal interaction testing, the generation of test stubs, and also user interaction testing.